curved surface refraction. This is the second lecture of the curved surface refraction, and in the previous lecture we have seen the derivation of the curved surface refraction formula. We have seen how to relate u, v, n1, n2 and the radius of curvature r when the light travels from one medium to another medium refracting at the curved surface. Now in the present lecture we are going to apply that formula. We are going to learn the skill for the application of that formula, how we are going to decide r, u, v, n1, n2, and we will see the numerical problems how we are applying that formula. See, when you will be dealing with the curved surface refraction, the situation or the problem can involve refraction at a single surface. Okay, it can involve refraction just at one surface, which you can call refraction at a single surface. Like in this figure, if you see, here we have glass. Okay, so on the right side there is homogeneity, overall there is glass, no other medium, and on the left side there is air. So when the light is coming from air to glass, it is getting refracted at one surface only. Can you see? It is getting refracted at one surface only, the air glass interface or the air glass surface. So such situations come in single surface refraction. After that we will see multiple surfaces refraction. Now in multiple surfaces refraction, what happens? There is refraction at more than one surface. Now if you see this figure, this is air, say this is glass, and again we have air. So when the light is coming, if you see a ray of light is coming like this, and say this is a point 1 and this is a point 2. So clearly you can see there are two refractions taking place. The first refraction is at air glass surface. Can you see? The first refraction is at air glass surface and the second refraction is at glass air surface. So such type of situation or problems will involve multiple refractions. Okay. So first in this lecture, in the present lecture, we are going to see the problems of single surface refraction, and in the next lecture we will be doing the problems for and the approach for multiple surfaces refraction. When you derive the lens maker formula, as I told you in the previous lecture, that curved surface refraction formula is the basis for the derivation of the lens maker formula, which is one of the very important formula for lenses. So lens has two surfaces. If you make any lens, suppose this is a convex lens. So we have surface 1 and surface 2. So when the light comes, it gets refracted at two surfaces. So lenses refraction will have multiple surfaces refraction. Okay. Now let's see how we will be applying the curved surface refraction formula. In lecture 1 of curved surface refraction, we have derived the formula. The formula was what? N2 by V minus N1 by U is equal to N2 minus N1 by R. Remember, that was the formula we derived. And we have seen the sign convention, and I recommend you don't go ahead in this lecture if till now you haven't gone through lecture 1 of this curved surface, because in that lecture we have seen the sign convention, how we apply the sign positive and negative, on which side will be taken as positive, which side will be taken as negative. So if you haven't gone through that lecture, first go through lecture 1 of curved surface L1, then come back to this lecture. Okay. So how you will proceed with the curved surface refraction formula in a single surface? First you will make, either the diagram will be given, otherwise you can make the cross-sectional figure as we have seen in lecture 1. Suppose this is your glass and this is your air. Okay, and say this is the object O. We know pole is the geometric center of the aperture, and the center will come on this side. So the light will be going from the object, so light is going from air to glass, isn't it? And we have seen in lecture 1 the medium in which light will be entering will be taken as positive. So this side will be taken as positive, and the medium from which light is coming in is taken as negative. So this side is taken as negative. So first of all decide medium 1 and medium 2. 1 is from which light is going and 2 is the one in which light is entering. So we have done so. This is medium 1 and this is medium 2. Okay. Then label plus and minus sign. So we have done the plus and minus sign for these principal axes. If you talk about the heights, we know upward height is taken as positive, downward as negative. Write u and r with sign. So say suppose the object is 18 centimeter and so the radius of curvature is 12 centimeter, okay? So the distance of object is denoted by u and the radius of curvature is denoted by r. So you have to write u and r with proper sign. So what will be u? Will it be plus 18 or minus 18? So u, the object is located on the negative side medium. So u in this figure will be minus 18 centimeter and radius is located on the positive side medium. So it will be plus 12 centimeter. Write n1 and n2. Remember in lecture 1 we have discussed what will be n1. The originating light medium, so air will be corresponding to n1, so n1 is 1, vacuum or air has a refractive index 1, and n2 will be the refractive index of the medium in which light is entering. So in this case glass, whatever the value of glass refractive index is given in the problem, that will be taken. Say for just to illustrate, if it's 1.5, so this will be n2. Then apply the formula with proper sign of input. And then you will get the output. Whatever is unknown, sometime V will be unknown, sometime U will be unknown, sometime R will be unknown. Okay, so suppose V is unknown and if V comes to be positive, so where the image will be located? On the right side. And if V comes to be negative, then where the image will be located? On the left side. Okay? And since refraction is taking place, any image will be located on the right side will be the real image, isn't it? Because on the right side only there is a scope for the rays to meet, and if image is located on the left side it will be virtual image. Got it? So this is how we will apply the curved surface formula. Now we will see some of the illustrations which will make it more clear how you are going to apply the equation with proper sign and how you are going to get the unknown. See illustration number 1. An object is placed at a distance of 20 centimeter in the rarer medium from the pole of a convex spherical refracting surface of radius of curvature 10 centimeter. So let us make a figure. Say this is the principal axis, okay? And since the convex surface is towards the air, so this is your pole. The object is at say how much? We will take the distance from the, don't write plus or minus in the figure. Remember, in the figure you are denoting just labeling the absolute distance. So don't put plus or minus sign in the figure. 20 centimeter and this is say the center of curvature and this is radius of curvature how much? 10 centimeter. Okay. If the refractive index of the rarer medium is 1, so you are given this medium. This is your rarer medium and this is your denser medium. So I am taking this as medium 1 and this as medium 2 since ray will go from medium 1 to medium 2. So N1 is 1 and N2 is 2, isn't it? So we got the values of N1, we got the value of N2. Now find the position of the image. So we have to locate the position of the image. See how I am making the ray diagram. Make one ray along the principal axis which will go undeviated. Correct? Make one ray along the principal axis which will go undeviated. Say like this. Make another ray striking a point on the spherical surface, say point A. Now make a normal at A. How will you make a normal at A? Make a line passing through the center of curvature. So this is your normal. Okay. Now let's see, let us put all the data. So what is N1? That is 1. What is N2? The medium in which light is entering. To what will be and which will be the positive side? So we know the sign convention. The medium in which the light will be entering will be given the plus sign and this will be given the minus sign. So U will be minus 20 centimeter. V we don't know. We don't know where the image is being formed. And what will be radius? 10 centimeter plus or minus. So you can see the center is on the right side. Center is always on the hollow side. So it is plus. Now apply the curved surface refraction formula. So I will have what is N2 2 by V minus what is N1 1 by U, and U is what? Minus 20 is equal to N2 minus N1 2 minus 1 divided by the radius of curvature, that is 10, and all the measurements are in centimeter. So you will get what? 2 by V minus minus will be plus 1 by 20 is equal to 2 minus 1 1 by 10. So I'll get 2 by V is equal to 1 by 10 minus 1 by 20, that is 20 minus 10 divided by 200, that is 10 by 200, that is 1 by 20, isn't it? Now you can make V as the subject. So 2 by V is coming to be 1 by 20, cross multiply, we will come to be 40, and the unit was centimeter. So this is your answer, V is coming to be 40 centimeter. Now see, V is coming to be positive. Can you see it? So where the image will be formed? The image will be formed on the positive side. What is positive side in our figure? The positive side is the denser medium. So image will be formed somewhere towards the right side of the pole. And if you need to make the ray sketch in MCQ, maybe it is not necessary to make the ray sketch, but since we are doing complete analysis, so see, had there been no change in medium, the ray would have gone like this, isn't it? Following a straight line path. Now it is going from a rarer to denser medium, so it will bend towards the normal, so it will bend like this, isn't it? And these two rays are meeting at this point, giving you the point image I. And this distance from the pole, this distance came to be how much? 40 centimeter. So this will be your answer. And how you write the answer? See, you have to specify the answer when you are writing the image. Write the distance of the image from the pole, number 1, that is the distance of the image from the surface, and number 2, on which side the image is being formed. So the distance of the image from the surface is 40 centimeter, and where it is formed? In the denser medium. So when we are writing the answer, we will be writing like this. Image is formed at a distance of 40 centimeter from surface on the side of denser medium. This will be the way to write the answer. You need not to write whether the image is virtual or real unless it is demanded in the problem. Like if it is said in the problem, tell the nature of the image in this case. So what do you think? What will be the nature of the image? Whether it will be real or virtual. So see, the image is formed on the positive side. The rays, where the rays are actually meeting. So the image in this case is the real image. Okay. So that is your illustration 1. Now let's see illustration 2. An empty spherical flask of diameter 100 centimeter is placed in water, refractive index 4 by 3. A parallel beam of light strikes the flask. Where will it appear to come from to an observer within the flask? So say we have an empty flask. Okay, suppose the flask is made of glass, and as we have seen in lecture 1, when in such cases the thickness of glass is not given, then we neglect its thickness and neglect the refraction through glass. Getting the point? So in this case, nothing is given about the material of the flask or its thickness, so you can neglect the presence of the material which is making the boundary of the flask, and you can assume there is air inside the flask, okay, and there is water outside. Outside we have water, and inside we have air. Okay, let us mark the principal axis. So I guess my principal, I am taking a blue line Okay, white line say. This will be the pole and this will be the center of curvature. And the observer is located inside the flux. So we have to consider just one refraction. Only refraction at this surface will take place. Getting the point? Because the observer need to see the image by his location inside the flux. So observer position is within the flux. So light is coming parallel. So if you make the rays, say we are making orange color or green color, so the ray will come like this. This parallel ray will come, this parallel ray will come. Okay. See, whenever the rays are coming parallel, it means the object is located at infinity. Remember, whenever it is said the rays are coming parallel, it means what? The object is located at infinity. So I can make this normal and I can make here another normal. So in this case, what are the two media involved? So light is going from water to air. So this is your medium 1 and this is your medium 2. You have to decide first this thing. So this is your medium 1, this will be refractive index N1, and this is medium 2, so this will be the refractive index N2, correct? So what is N1? The refractive index of water, that is 4 by 3. What is N2? The refractive index of air, that is 1. What is the radius of curvature? So dia is 100 centimeter. So radius will be 50 centimeter. Now which will be the positive side? What do you think? Whether water will be the positive side of principal axis coordinate system or air will be the positive side. So pole is acting as the origin, we know, and rays going from water to air. So air will be the positive side and water side will be the negative side. So radius will be plus 50 centimeter. What will be u? U is infinity. Remember, as I told you, whenever it is being told that rays are coming parallel like this, u will be infinity. And if it is said in the problem that rays are emerging parallel, then v will be infinity. That means the final image will be formed at infinity. Got it? Now if you see v, we don't know. Now apply the curved surface refraction formula. N2 by v minus N1 by u is N2 minus N1 by r. So what you will get? What is N2? 1 by v minus what is N1? 4 by 3 by infinity is equal to N2 minus N1, 1 minus 4 by 3 by the radius of curvature, that is 50. Now you know 1 by infinity will approach 0. So you will have the equation 1 by v is 3 minus 4 will be minus 1 by 3 into 50. So if you cross multiply, v will come to be minus 150 centimeter, isn't it? So see, you are getting v as minus 150 centimeter. Now what is the significance of the negative sign? Now the negative sign here means the image is formed on that side of the pole where the axis is negative. So where the axis is negative? The axis is negative on the water side. So the image will be formed. How we write the answer? The image will be formed 150 centimeter from the surface of flux. Image will be formed 150 centimeter from the surface of flux on the side of water. On the side of water. We will write the answer like this. Image is formed at a distance of 150 centimeter from the surface of flux on side of water. Got it? Now if you want to make the image, again I am saying making the image is optional. If you are doing MCQ, that is enough. We need not to proceed further. Because you already, you need not to make the ray diagram to get the answer. You see the beauty of the curved surface equation, you are getting the answer without the ray sketch. If it is being told that make the ray sketch, Or suppose you need to make the ray sketch for your visualization after finding the answer, then you can always make it so. So say here the ray is coming and this is the normal. So had there been no change in surface, it would have gone something like this. But since the surface is changing from water to air, from denser to rarer medium, it will bend where? Ray is going from denser to rarer medium, it will bend away from the normal, so it will go something like this. And since rays follow rectilinear propagation, so we will produce this backward and they would be appearing to be coming from this point. So this is your image as we have seen. And from the pole, always you take the distance from the pole, this is how much? 150 centimeters. Don't write here minus. Already you are showing the image on this side. So you can convince also from the ray sketch that image is virtual, that is on the water side. Got it? Now see the next problem. In the adjoining figure, a parallel beam of monochromatic light is incident on a convex spherical surface of this much radius which separates glass from air. Find the position of the image formed due to refraction of light at this single spherical surface. Now I guess, can you solve this problem yourself? This is your medium 1, correct? So N1 is 1, this is your medium 2. So N2 is how much? You are given the refractive index 1.6. Okay, this is the pole, this will be the positive side, this will be the negative side. What will be U? U will be infinity, correct? Because the rays are coming parallel and you have to find V. Radius will be plus 30 centimeter. So apply the formula. N2 by V minus N1 by U is N2 minus N1 by R, and find V and write the answer in proper sentence in the comment box. Okay, write the answer with proper sentence in the comment box. Proper sentence means you will tell the distance of the image from the surface and the side, the medium in which image is formed. Okay? So this I am leaving for you to do and write the answer in the comment box. Now see illustration 4. A small air bubble is entrapped in a glass, refractive index 1.5. So we have a glass sphere of radius 4 centimeter, and in the sphere there is a small air bubble which is entrapped at a distance of 1 centimeter from the center of the sphere. Where will the bubble appear when seen through the glass surface? A, nearest the bubble, farthest from the bubble. Okay, see. So we have a situation something like this. There is a glass sphere. Okay. This is a glass sphere. You are given the radius of the sphere and the refractive index is 1.5. Okay. So this will be the center of the sphere and the radius is 4 centimeter. And the bubble is trapped where? At a distance of 1 centimeter from the center. So say this is the bubble. I am writing O. This is your air bubble. And you are observing the bubble from outside. You are observing the bubble from outside. So be very much clear which is the object. So in this problem, the object is your air bubble, correct? The object is your air bubble and you are the observer. So you need to find where the bubble will appear. Where the bubble will appear means where the image of the bubble will appear, where the image will be formed. So in this case the object is air bubble and you are observing from two sides. Part A, nearest the bubble, that is from the side when you are nearest to the bubble, and in another case B, you are observing from the side when you are farthest at maximum distance from the bubble. Okay, so see case 1. Let's see case 1. Case A, I am making the principal axis. So this is the principal axis, okay, and where you are located. So this is the side. See, bubble is here. And this is the distance, how much? A bubble at a distance of 1 centimeter from the center. So when you are on this side, you are nearest the bubble, okay? So just think where the light will be going. This medium is air, this is glass. So just think for 1 minute. In this case, light will be going from air to glass or from glass to air. The bubble is the object is located in glass. So of course the light would be reaching my eye from the object. So light would be reaching from the bubble to the eye. So light will be going, if I am making a rough schematic figure, so light is going from glass to air like this, isn't it? Because object is here in the glass side, so light is going like this. So this is the pole, which side will be taken as positive. So the direction of incident ray is like this, the direction of light is like this. So air side will be given the plus sign and your glass side will be given the minus sign, isn't it? Be careful, say in most of the problems, usually most of the problem give you the situation in where the light is coming from the left side and going to the right side. So in such cases, right side is positive, left side is negative. But see, in many problems like the present one, light goes from the left to right. So be careful about taking the sign which medium will be positive and which medium will be negative. So this is your N1 now, because originating medium is given 1 and this is your N2. Okay. Now write all the data with proper sign for case 1. So for case 1, what is N1? The refractive index of the glass, which is given how much? 1.5. What is N2? The refractive index of air. What is U? So U will be this much distance. So your radius is how much? 4 centimeter. So this is 1 centimeter. So bubble from the surface would be at 3 centimeter, or plus 3 or minus 3. So already we have seen this is the negative side. This will be minus 3 and your V is unknown. And what will be the radius of curvature? So radius is on the negative side. So minus 4 centimeter. Now apply N2 by V minus N1 by U is equal to N2 minus N1 by R. So I'll get what? 1 by V minus 1.5 by minus 3 is equal to N2 minus N1 divided by what is the radius of curvature? Minus 4. So you will get 1 by V minus minus will be plus 1.5 by 3 is equal to minus 0.5 by 4. So 1 by V will come to be, this is also minus 0.5 by 4 minus 1.5 by 3. So 1 by V will come to be 0.5 divided by 4 minus 1.5 divided by 3. So we'll get minus 0.375. 0.375. So V will come to be how much? We have to just inverse it. So V will come to be minus 2.666 centimeter. So you can approximate as minus 2.7 centimeter. Now see, V is coming to be negative. V is coming to be negative. What it means? It means the image will be formed on the negative side. Negative side means where? The image will be formed on the glass side, inside the glass sphere, at a distance of 2.7 centimeter from the surface. The image will be formed somewhere, between P and O on the side of the glass. So in case A, you can write image is formed at 2.7 centimeter from glass surface inside glass. That is the answer. Again, the same thing if you want to make the figure. So make one ray. Ray will be originating from the object. So make one ray going along the principal axis. It will go undeviated, isn't it? Make another ray like this. Now make a normal. So for making a normal, make a line passing through the center of curvature like this. So this is the first ray before refraction, after refraction, this is the second ray. Now had there been no change in the medium, it would have gone like this, but since it is going from denser to rarer medium, it will bend away from the normal, it will bend something like this. And from the outside observer, it would be appearing to be coming in a straight line, so you can extend it backward. So here it is meeting with this ray, so this will be the image. And this distance came to be how much? 2.7 centimeter. So if some observer is observing from this side, he will see the image at 2.7 centimeter from the surface inside. Okay, this is your case A. When you are observing the bubble from the side when the bubble is nearest to you. Now let's come to case B. Now let's come to case B. You are observing the bubble from the side when the bubble is at maximum distance, that is farthest from you. So already I have pasted the same figure. Let me make the principal axis now. Bubble is this. What will be the, this is 1 centimeter. So what will be the, now this will be the pole, isn't it? Now light is going like this from glass to air, because this will be the side of farthest distance. So you will be observing from this side. Okay. So this is the object. What will be this distance? The distance of the object from the pole. Now this is the refracting surface for case 2. So we have to measure the distances from the pole of the refracting surface. In case 1, left surface was the refracting surface. In case 2, right surface is the refracting surface. So that was 1 centimeter, this is 4 centimeter. So this comes to be how much? 5 centimeter. This will be the radius of curvature. Which side will be positive? So this is medium 1, this is medium 2, this is N2, this is N1. Light is entering in air, so this will be the positive side, this will be the negative side. So what will be U? Object is here, of course your U will be negative. Minus 5 centimeter, V we don't know. What is N1? Refractive index of the glass, that is how much? 1.5. N2, refractive index of air, 1. And what is your radius of curvature? 4 centimeter, and that is located where? On the negative side. So let us apply the curved surface formula. So I'll get N2 by V minus N1 by U is N2 minus N1 by R. So I'll get what? N2 is 1 by V minus 1.5 by minus 5 is equal to N2 1 minus 1.5 divided by what is R? Minus 4. So you'll get 1 by V plus you'll get 1.5 by 5 is equal to minus 0.5 by minus 4. So we'll get the equation 1 by V is equal to minus minus will be plus 0.5 by 4 minus 1.5 by 5. So I'll get 1 by V as what? Let me calculate. So I'll get 0.5 divided by 4 minus 1.5 divided by 5. So I'll get minus 0.175. So if we inverse it, 0.175, you will get 5.7 centimeter. So V will come to be minus 5.7 centimeter. And negative side is telling you that it will be formed on the medium with negative side of the pole. So what is the medium on the negative side of the pole? That is the glass. So it will be formed at 5.7 centimeter inside the glass from the pole. So see, this is 4, this is 5. It will be formed beyond O, something like this. Can you visualize? So your image in this case will be, you can say, image is at 5.7 centimeter from the surface inside glass. And if you want to make the figure ray sketch, let's see how we'll make the ray sketch. So I will make one ray going along the principal axis from O, like this. This will go undeviated. Then I will make another ray striking some point on the glass air interface like this. Now make a normal at this point, so you can make a line passing through the center of curvature. Had there been no change in medium, this white ray would have gone, let me make a dotted path, would have gone something like this, had there been no change in the medium, correct? But since it is going where? From denser to rarer medium, it will bend away from the normal. So it will bend something like this. And to an observer who is observing from this side, it would appear to be coming in a straight line, so you can reduce it backward, something like this. So this extended virtual ray is meeting this ray, virtual ray backward image, and this distance we have calculated, this whole from the pole, this came to be how much? 5.7 centimeter. So this is the ray sketch if you want to make. If it's only the problem is demanding only the answer value, numerical value, so you can write 5.7 centimeter from the surface inside the glass, that's it. So in this lecture we have seen what? Number of problems involving the application of the curved surface refraction formula for single surface. Now in the next lecture we will see how we will apply the curved surface refraction formula for multiple surfaces like this. Okay, the principle will be same. We will say first image will be acting as the object for the second refraction, but before that go through this lecture, absorb all the concept, then we will proceed with the next lecture.